Hello everyone, I hope you all are doing well. This side Priya Bhatia, and in this video we will be discussing about the implementation of regularization techniques that we have covered up so far. So if you have observed, we have discussed in a lot more detail about the linear regression, what is its mathematical intuition. Then we have seen that there exists a problem of overfitting in few types of data sets. That is where we have understood the concept of bias variance, when these kind of problems usually happen, when these kind of errors usually happen. And that is where, in order to avoid that overfitting in a given model, we have seen about the regularization techniques till so far. With respect to regression problems, we have seen majorly, I would say, two different types of regularization techniques. One is L1 and another one is L2, which is another, in another form, it is also called as lasso and ridge regression. And then we have talked about elastic net, which is a combination of somehow L1 and L2, which is a combination of lasso and ridge. Now, in this video, we will be covering up the implementation of the same with respect to the house prediction data set. Let's assume that, until so far, we have seen in our hands-on of linear regression part, house predicting, if you remember, that project we have covered up end to end. In that, I have shown you the complete end to end pipeline, right? That how can we basically implement the linear regression algorithm on top of that data set of California housing part. Now, let's say I'm saying I want to apply a lasso or I want to apply a ridge regression, and I just want to see the score that how it is behaving. So, how we can do the implementation for the same? Today, we will discuss that part. So, our complete focus on this session is just on the implementation per se. So, if there is anyone who is not comfortable with the internal mathematical intuition behind the same, so I would highly suggest that first of all, watch that video, then only please move ahead with respect to the implementation part. Otherwise, it will be very confusing for you. So now I hope that you all remember the implementation of this file where we are predicting the house prices with respect to the linear regression algorithm implementation. I have shown you step by step in every video that how from the phase of data collection till the saving the file and doing the predictions, how these things will go, right? Just to give you a brief recall, if you remember, we have tried to fetch the California housing data set. We have seen that how we can do the data preparation part of the same. We have tried to prepare the data, convert it into a data frame. After that, we have tried to see that, what is the top 5 records looks like, how the top last 5 records looks like. After that, if you go below, we have seen the EDA portion where we have tried to target the statistical description of the data. We have tried to see the correlation heat map, right? Box plot in order to check the outliers available in my data set. After that, we have tried to split our data into independent and dependent features. So here you can see the y value is the target value, which is the price of a house, and x contains the features of the house. For example, you can see here median house age, average number of rooms, average number of bedrooms, population, average occupation, latitude, longitude, and everything is given here. Now, we have tried to split our data into training and testing in our earlier file with a ratio of 30%, which is going towards the testing part, and 70%, which is going towards the training part. And then after that, we have seen how we can do the normalization of a data by applying a standard scalar, right? After that, we have seen the difference. And then at the end, we have tried to do the model training where we have applied the linear regression model. Now we have seen that how our metrics looks like, and this is the numbers that we will be able to get, right? After that, we have tried to see the difference between r square, adjusted r square. We tried to save our model, and at the end, we have seen how we can load that same file in order to do the predictions, so that in future, let's say I have a very big data, I don't want to retrain it again and again, right? It doesn't make sense. So we have seen that with the help of pickle, how we can save that coefficients, that file, and then how can we load that in order to give the outcome. Now, today in this video, our focus is to talk about that on top of this file itself. Let's say I want to apply a regularization techniques, maybe L1, maybe L2, maybe lasso, maybe ridge. L1 and lasso is one and the same thing. L2 and ridge is one and the same thing whenever I'm saying. So now how basically we will be able to work upon that. That is the simplest task which we want to see here. So again, first of all, we need to import those files, sklearn.linear underscore model. The function names are lasso and rich. So you can just mention lasso followed by rich. These two function names I want to work upon, basically used for the regularization per se. That is what we have seen, right? So this is basically used for the regularization, means to avoid the overfitting in the model. Okay? Now, what we can do here is we can try to first of all create a rich model. It's very simple. It's just that mathematical intuition understanding is bit difficult, but I always say ki implementation is very simple because we already have functions defined with us. Let's say rich is the function that we have. Now in this function, there are different parameters. Maybe let's say, if you remember in the cost function of ridge, we have a lambda, right? Like how much strength, uh, alpha or lambda, one and the same thing. So we have alpha. So how much is the strength with which regularization will happen? And this is something which is a hyperparameter. So as of now, I am choosing this value as 1, but at your end, you can try when you are choosing the value as 0.1 or maybe 1 or maybe 10. So you can check it out that on which particular value of alpha, it's an experimental value again. Depending upon what kind of data you are dealing with, it might change. But for now, I am just referring this parameter of alpha, the strength of regularization value, as 1 by default. Okay, I'm just referring this 1.0. Now you can change it depending upon that. Check out the values that you are getting, whether it is apt or not, or which particular value of alpha is giving us a more appropriate result. This is your task. Please try to do it at your end. Now, what I will do is I will try to fit this model on the train data. Now, what is the train data that we have? I think our train data is x underscore train underscore norm, and our corresponding value is y underscore train, if I'm not wrong, right? Similar to this, we will try to create one more model. So let me just paste it over here. But another model is lasso underscore regression. So we will try to call our function name by the name of lasso, and we will try to fit this model as well on the train data. Now, what will happen is we will be able to have two models with us. One is with the name of lasso regression, another one is with the name of ridge regression. Let's try to fit these models. Let's run this model. So I believe both of them have run properly fine. Let's try to do the prediction with respect to the lasso regression first. So this is the model name we have, dot predict, and we want to do the prediction on the x underscore test underscore norm, right? Let's see what is the kind of predictions we will be able to get here. So we will be having some values which indicates the price of the house. Similarly, if you want to check the predictions by the ridge regression, it's again very simple. We have a predict function where we can check x underscore test underscore norm. So simple, right? Norm. So we will be able to have some indications with respect to the prediction part in the ridge regression as well. Now, the question is, how can we evaluate that? In order to evaluate that, maybe we can use all those scores metrics which we have used here. Maybe we can go for mean squared error. Maybe we can go for, you can say, mean absolute error, right? R2 square, NP square root. Maybe as of now, let me go for this part where I'm just trying to check it out. The root mean squared error, where I'm passing the y underscore test, and let's say I'm passing the lasso regression here, which is my first model which I have created just now. Now let's try to see what is the value we are getting here. So there is some issue which we are getting here. Let's try to understand where this test case is failing. NP dot square root, what is the error? Maybe there is some bracket issue. Let me just figure it out. I believe it is fine. Lasso underscore regression is my model name. Y underscore test is the, I think, test data that we will be having. Let me just check it out. I feel yes. NP dot square root. Let's try to see here. NP dot square root, mean squared error. y underscore test. Let's try to run this same issue. Let me try to work for ridge regression as well, and let's try to figure it out whether we are getting a similar kind of a issue there as well. Okay, so there must be some issue here. Ridge underscore regression. Okay, let's do one thing. I think the issue is we are not storing the predictions anywhere, and that's the main reason I believe the issue is coming up. So what I can do is I can try to store the predictions by the name of lasso underscore pred, and that is where this will look fine now. And here also let me do one thing. Let me store the predictions of this ridge as well in the uh, you know underscore pred. Now I feel things should work fine because it is great. We will store the predictions and then we will check the RMSE. A lasso. Okay, let me run this again. This also, and let's try to print it again. So now we are getting a correct value. Let me try to print the same number for the other metric as well, which is ridge predictions. And let's try to figure it out whether what number we are getting. So now you all are aware, right? Here we are trying to conclude our RMSC, right? And you all are aware that root mean squared error should be lower. Lower the value of RMSC, it means that our model is working perfectly fine. So, what we want or what we can see here is that somehow rich regression in this particular case, if I want to compare between L1 and L2, or if I want to compare between lasso and ridge, I can say that ridge is somehow having a good number as comparable to the lasso. But definitely we can do more optimization on top of this. And first of all, we need to check that genuinely it is required or not. Because as I said, that it's a overfitting regularization technique where we want to avoid that situation of overfitting. So first of all, is that happening or not? That is the important point. If yes, then which kind of technique we should apply? Definitely this is how you have to do the implementation, and then you have to check that what is the number you're getting as a form of RMSC. Apart from this, definitely in future we will talk about other different kind of regression algorithms. So maybe when we will apply other algorithms apart from linear regression, this number might look better. So these are the techniques to optimize this number, but anyhow, the focus is on the implementation per se. So now I hope it is clear that it's very, very simple to implement the lasso and ridge regression, which are regularization techniques that we have talked about so far. So in this case, it's just that it's already available in our linear underscore model, and we just have to import those functions. Now, as I told you, one important thing is to optimize this parameter as well. We can work upon with the numbers that which number looks better. Maybe there are usually you will see zero point 0.1, 1.0, and 10 is a quite famous numbers. You can work upon this that which number is the perfect one experimentally, or we will in future discuss about hyperparameter tuning. So that is where we will talk about that all these parameters, how can we optimize as per our dataset as well. But anyhow, this is where we have fixed our number for now. Also, apart from this, I will also prefer that you will also refer the documentation of sklearn, where this ridge and lasso functions are defined. It will really help you to understand in a more appropriate manner. But anyhow, I hope that the implementation is pretty much clear to everyone. With this, I think let's end today's video. I will see you all in the upcoming video where we will discuss further amazing concepts of ML. I hope that you are enjoying this course. Stay tuned. I'll see you all very soon in the upcoming course.